Hello and welcome to UPAS ESP32 wireless audio video intercom. This project I've been working towards for the last sort of 10 years, although it did start out with non-wireless technology, but slowly, I don't say we're going over to it, but extending it onto. So anyway, I thought I'd give you a bit of an introduction in case anyone's interested. The hardware is all open source hardware, so it's all available, and there's various bits of code across the internet that you can use to access each part. So let's just go through what we've done. I've just got it in SketchUp at the minute, modelled. What I'm trying to do is position all the equipment onto the front plate. So we've got an Rfid reader. I'm just going to lose the reader a second. And we've also got underneath here the standard RF module. I forget the name of it now, but I've got it somewhere. What have I called it? Yeah, so RFID, it's Rc522, so it's using one of those cheap Rc522 PCBs you can get, and I believe it's wired via SPI. So the other one we've got, this one here is an RFID reader, which you can buy as well off various places, and that is a Wiegand 5 volt. So we've had to do some logic level conversion onto the ESP32 to get that to work, but it works okay. So we'll just get rid of that. I'll leave it there, won't it? Right, so we've got a speaker, an 8 ohm Mylar, so waterproof speaker, Mylar. I'll show you that in a minute. We've got a illuminated push button. We've got a 320 by 240 TFT touchscreen display. We've got a ESP cam, and we've got a little microphone I forget the name of now. I'll show you that, you'll probably spot it. It's a MEMS mic, I believe, so we'll have a look at that. So we've got the main front plate is 200mm by 150mm with 5mm capability for 5mm fixings to hold it in. This plate is designed to be desk mount or wall mount, so you have a cowl to go. If you're going to have it on a wall mount, you'll have a surface cowl. For a desktop, you can have a nice wooden cowl or whichever one you want to make it look, and you can change the angle. I've yet to do that bit. Alright, so what we're going to do now is I'll just give you a spin around. It's in 3D. Model it in 3D because I don't want to keep doing. In the past, I've built stuff and then found out that something's too close or fixing, and you need to make another prototype, or and you keep on and on. You end up with loads of parts that you've, a big load of revisions. So it's quite interesting to see some of the earlier revisions, but anyway, so I'm just going to give you a spin around. So but let me just show you some of the layers. This top layer here, let's get rid of that and get rid of the polycarbonate layer. Alright, I'll tell you what, let's get rid of most of it. Let's get rid of the TFT display. Where did I put it? Let's get rid of the camera. Let's get rid of the button. Let's get rid of the speaker. Let's get rid of the RFID reader. Does that leave anything? Oh, let's get rid of the microphone. Oh, we've got rid of the mic. That's OLED display. Let's have a look. So let's have a quick peek to what we got left. Right. I've got my clamps. I've got to get rid of my clamps. Don't worry about speaker clamps. Tell you what, let's just go and basically I wanted to show you the front plate first. So this front plate, it's 1.2 mil black anodized aluminium plate. Okay. I've got some materials, so I'm gonna. This is gonna be CNC milled out. Let's get rid of the mic. Where's the mic? Yeah. So this is going to be milled out of a, and it'll mill out all the holes ready. Mill out the hole for the Rfid reader frequency to get through past the metal. So there's a bit of plastic there. They've got speaker grill, microphone grill, camera cutout, and the display and the push button. So that's not very exciting, but anyway. Right, so what we'll do now is we'll get rid of the aluminium and let's get the polycarbonate. So this is a piece of clear polycarbonate. Now your TFT aluminium 1.2 mil sits above that, as you can see there. And basically that's just a plate, so when you bolt it through, your friction will go through there and it'll hold that onto there. Might be a rubber gasket going in here, I don't know. So get rid of that. So you've got your polycarbonate. Obviously where the TFT display, let's put that TFT back on. This TFT display you've got here, obviously it needs protection. You can't just have that out into nowhere, so that'll just sit underneath the polycarbonate, the clear polycarbonate, and this is a total piece of clear polycarbonate, so everything's clear. It also let the camera through. Let's put the camera back on, and I might as well put the microphone back on as well. Alright, so you got your microphone there. I'll also put the microphone PCB. I'm gonna have to make a PCB to sit got to design a circuit board yet that makes this microphone work with ESP32 cam. There's going to be 2 ESP32s on this device. This audio module, yeah, I'll just provide 2 for the sake of what that is. I'll just, price of that, you might as well just. Got 2 devices actually. I got another gadget here. I'm just going off on a bit of a tangent. Let's turn it round upside down so we can have a look. Now this is the UPAS KP V2. This is my main circuit board that I'm building at the minute. Design and build. Already got it built. So we've got here an OLED that can be reversed round underneath there. That's just me trying stuff out. So it uses an ESP32 node MCU V1. That does. Okay. We've got a TFT display port. It's a LARLin pinout, which is that device there, that TFT display. That's your LARLin display there. So there's a little link cable plugs in from there over to that. We've got a onboard stemmer connector, Adafruit stemmer connector. So you can put sensors, real-time clocks, anything else that you want to put on it. Temperature sensor maybe if you want to do temperature. We've got an external I2C LCD port for different configurations. This is onboard sounder, or piezo, and relay. So you've got 12 volts coming in. We've got a little mini 360 buck converter doing some 12 volt down to 5 volt conversion. Little reservoir capacitor just to stop any brownouts from this. Onboard fuse, 500 milliamp poly fuse, and reverse protection diode. Don't know what they're doing there. That must be off an older model. Got to take them off. They've come in off another design, off one of my earlier ones. I got another one of these. It's designed for an ESP. Sorry, a tiny Pico. But tiny Picos, about to go onto ESP32 node MCU. I'm trying to keep the costs right down, and Xeon, it's the costs at the minute are quite high on the tiny Pico. So I've still got that design, but I'll keep this one for now. See what I can do with this one. Okay, so let's put the speaker back on and the push button. Let's talk about the push button a minute. This is it's got 4 terminals, 2 for the contact and 2 for the LED. It's an illuminated button, so when you press it, obviously the microcontroller can do all sorts of flashing and stuff with this if it wants to. Got your speaker there. It's a Mylar, as I said earlier. A couple of clamps. Alright, what else we got? Let's put on the reader. Right, this PCB here is the Rc522 chip. So this is an SPI Rfid Reader. I think it's 13 something megahertz, as opposed to this one, which is your standard 125 kilohertz. Is it 125 kilohertz style of proximity? Anyway, so if you're not having whichever one, you just lose whichever one you don't want. So you just lose that one, have that one. Okay, let's put the front plate back on. So there's your front plate. So let's just go through a few functions here, what we're going to get. So if you could imagine this on got TFT screen, so the user will come up to the intercom, press the button, and you'll have a welcome screen to start with. You press the button, and it'll if there's only one call position, so if you've only got one sort of business or premises or office or whichever one you want to call, bedroom, whatever, it'll just call straight away that one. But if you want to have multiple businesses, you don't have to have multiple buttons like traditionally. You'd have another button, one for one business, one for another, and so on and so forth. So you haven't got none of that. So what you do, as soon as you got more than one programmed in, it'll just show you a list, or it'll show you a list probably and show you the selected one, and you press it again quickly and it'll select the next one. Press it again, it'll select the next one. Press it again and select the next one. Get to the end, it'll go back to the start. As soon as you let go for more than a sort of so many milliseconds, half a second, a second, it'll say hold to call. So you press it quickly to toggle the business or person you're going to call, hold it to call, and once it calls, it'll give you feedback for the audio. It'll mix some audio in. It'll say calling, you know, and once it calls, during the call you could press it again to cancel. It'll say to cancel, press again, or press and hold to cancel, that kind of thing. So it's designed to be modular, so this can be, the same panel can be used outside and inside. So if it's outside, it'll be upright like that. If it's outside, it'll be on your desk, sort of thing, with a cowl. I haven't done the cowl yet. I've done cowls before. So your cowl will be there, and you can have it different angles and whatever. And it's basically the same setup again, exactly the same setup again. Now, if you had one of these in one office and one in another, you could actually call each other if you wanted. So the one outside that's like that could call, it'll basically call whichever business or all at the same time. So if you press a button, it'll ring the desktop ones in the office A and the office B, and whoever wants to answer it will just press a button. So that'll answer the call, and once the call is underway, it'll cancel the ringing as soon as somebody takes the call, so don't have to worry about them carrying on ringing. It'll then, this is the one in the office or the reception, it'll show you a picture on the screen of the user via that camera there. The one outside, so the one outside, instead of it showing you a picture on here of the person in reception, it's just gonna show you a picture of yourself. It can show you a picture of yourself initially, or just give you instructions, or not show you a picture. Then you got your microphone there. So basically, stream audio and video. How the we've got some main Windows software. It's called UPAS also. So the UPAS software will talk to this device. The button will be wired to the input over here. One of these programmable inputs. The default to be an exit, contact, and tamper. So one of these inputs, the wire will go to. The LED for the button will go over to the reader LED. You've got data 0, or clock and data on data 0, data 1. You've got your LED. It's normally for the reader. So your reader LED there. Sorry if I'm making you feel seasick. That LED goes from red to be power to green, and sounds an internal buzzer whenever you operate, where it coincides with that LED pin there. So that'll be wired into that. Your speaker, it's got to go into, we've got to make another board yet. I've got one for the microphone. Maybe I can include that in the speaker for that. It's a good idea. So microphones, let me show you the mic. I haven't showed the mic yet, have I? The microphone's there. Now this is one of those MEMS mics. And that, you buy these and just 6p and just plug them in. Here we've got the ESP32 cam. That's just the standard ESP32 cam. All spacing is set up here to be able to do, so it clears the polycarbonate so the lens doesn't touch anything. Right. So yeah, so I've got to add another connector. That's 12 volts into this, 12 volts into that. They'll have to be connected up. I'll probably need, if the speaker can either go over to this one or over to that one, but that's got the mic. So I think I'm gonna have to wire it over to this one. It's gonna have to have another connector put in. Another one of them. Just there, maybe a small one. Might have to alter. This PCB hasn't been made yet. This one, I haven't made that yet. I've just got a breadboard and put the mic and the ESP32 cam on a breadboard, so we're going to get that working. It's probably going to have to do the speaker as well. So that this PCB will have the little 3-watt amplifier, or I2S amplifier. This is I2S microphone. So it'll be doing a bit of I2S. Possibly there's another ESP on here. This is ESP node MCU that's running all this lot and doing all the token data and handling the TFT display. You could possibly do it all from one, but I'm using a lot of the pins already. I've got a spare relay 2 and 3 there, which is just an output off the, where's it coming from? Off this octal Darlington driver, which is being switched by that there. So I could convert them into microphone maybe. It's a bit of a weird one, whether we have mic going into there and just that's the camera. Be nice to do microphone on this one, microphone and speaker off this. Then if you don't want, yeah, it's a bit awkward. Unless I make one big one, but I don't want to tax the system too much, and these are quite cheap. You can buy the industry I'm in. We do access control and all sorts of stuff, and we've had to replace camera modules in the past in the commercial proprietary stuff off the shelf. They're asking £400 for the camera module, and these at the minute are sort of about £10. I know they're gonna go up on all sorts of stuff, but it's still cheap. So the idea is to make an audio video intercom that doesn't cost a fortune. That's replaceable parts. TFT goes funny, change it. Button goes funny, change it. Speaker goes funny, change it. RFID goes funny, change it. Camera goes funny, change it. Microphone goes funny, change it. This goes funny, just buy another one. Send it back. Anyway, let me think if I forgot anything. So the reason for doing this 3D design, put a lot of work into this, is, which paid dividends really, because I've put this together today, and I've got to space the camera, space the microphone and the camera just right. And it's got to have some fixings, and you've got an SD card slot there, so you've got to make sure your fixing here doesn't get in the way of your card slot, which it doesn't, and you can still get your finger under or screwdriver to press that if you ever need to. Probably never need to press the reset. And you've got to make sure all this kind of stuff, your TFT, your Larlin display cable, can physically get out. Add that connector here initially, and you wouldn't be able to plug the connector in. So you just got to make sure it all fits really, and as well as that, I've got to make sure there is clearance for the cowl lip. So that's I've got to make sure there's nothing around this edge here, because I want to make it. I'm going to laser cut a rubber seal to go around this, probably all around this, and when you screw it back it should seal it well. And they're raised off anyway, so if it doesn't get any water coming in, it should just pass through, and the cowl will have drain holes. So now there's another idea I had, if I can turn this on its side. You've got the front aluminium milled out for the speaker. Now, in order for the rain not to go straight in here, I'm going to offset these holes back a bit. So basically, the hole comes up, across, and then through the top plate. So the rain has basically got to go uphill. The rain will have to go uphill, sort of like that. If you pretend it'll have to go in and uphill, which it doesn't do. So, but the Mylar speaker anyway, so it's waterproof anyway. Because a lot of intercoms, they fail due to water ingress. So we don't want none of that. But it's not the end of the world if something just get water ingress. Probably put conformal coatings on this stuff as well, a bit of spray lacquer. But it's not the end of the world, as it would have been with proprietary Intercom, where the camera module's £400. These are readily available. So it's a bit of a weird one. So the idea of the software would be, press the button, it initiates a call to this input, which initiates a call to the main software or another one of these, or multiple ones of these, and then the software or the one of these units then activates the command to switch on the camera and audio off this. So this is like just a dumb slave unit that just switches on whenever this asks it to switch on. So it's communicating with packet data back and forth, either from here to the main software or here straight to this device. Because in reception you don't actually need another one of these if you don't want to. You can have a software version that runs on a Windows desktop. As long as you've got a headset and microphone, you could take the call on a software version, which I will show you at some point on the next video. So what we got 26 minutes. That's quite enough time for a while. Let me just give you some zoomed in stuff. Let's give you a bit of zoomed in on stuff. Alright, what can we zoom in on? Something interesting. Yeah, I've created all this stuff myself. Couldn't find a lot of this circuit board. Was designed by me. This micro USB, I've sort of copied it as near as damn it from the physical one. The buttons I've redone them. The LEDs I've had to make myself as well. I've even gone too far to put the wire in and the pattern, so I might as well. Yeah, so this controller, it's got RFID input, TFT display, stemmer, QT, relay, speaker, 3 inputs and a program button, OLED display. It'll take a standard 16:2 LCD display there as well. That's it, we pretty much covered it. It's got the 12 volt to 5 volt buck converter, and that is it. Display is from the LAL install. That's that display is from. And just buy the ribbon and plug it in, save running extra cables. But this when I developed this board, I know didn't want this to do display. I want to just keep the video stream this doing as least work as possible. I didn't want to have to update display. So that's hence why what's doing that work, excuse me. Anyway, I think that'll about do it. So if you're anyone's interested in this project, yeah, so if anyone's interested in this project, leave some comments. And I've seen all the samples for doing MEMS microphone and speaker. I've got all the bits here. I can't show you at the minute. I haven't got an external camera. So I've got that one. I don't want to move it though. We'll do some more videos and see if I can get any comments on it. But I'm about ready to. I'm just been positioning all this stuff, and I need to get some sizes off it. So I'll be able to mill out the polycarbonate and the front plate. And there's one thing I forgot to mention as well. This front plate, because it's anodized, you can laser cut it. You can laser the anodize. So if we need to put a logo on or anything, So if you need to put some graphics or logo or even some livery on it, bit of livery. If you wanted to say that this is a mic, this is a speaker, that's the camera, microphone, TFT. You could do. You could put some information. You could basically just laser, like they do on drinks containers and stuff. You could laser the anodize, which I probably do, but you could even do an on-body print with like a frame around it or something. But the idea was supposed to be universal, really. We've got 30 minutes. Yeah, so I'll end it there. Hopefully, if anyone wants to leave any comments or anything like that, no problem, we'll have a look at it. Okay, so there's a bit of a mumbling on. Thanks for listening. I'm trying to generate a bit of support for it. I spent hundreds of hours on it since 2012 on the system. Set up a company 2018 just to sell some of the items. Sold a couple, and then I haven't bothered because I've been adding features to it. Got a bit of feature creep going on, but the whole idea was to be able to encompass a building or buildings. So you got your access control on your doors. You got your audio video intercom anywhere where there's a perimeter. So the UPAS stands for Ultra Connect Perimeter Access Surveillance. So the main software does we're able to capture cameras. Don't want to make it into a digital video recorder because you can buy them. It's just gonna, when you initiate an intercom call, you can capture it. It'll automatically capture whatever's gone on anyway. Keep it just till it rolls over. There's loads more to mention, but it's fully programmable. So if you've got people pressing the button or messing around with the system, you could set it to automatically turn off certain features or power down and all sorts of stuff. So there's no limit really. So anyway, let's see if I can generate anything. I'll put it on my normal YouTube channel. Might have to set another one up. I've got to do some video tutorials soon on how to do certain things on the software. Might do a few live streams soon. Just getting a better broadband. So anyway, I hope I didn't bore you too much. And if anyone else is interested in seeing how we go on or suggestions or anything, no problem. Okay, so next time we do one, hopefully I'll have all the cowl ready for the surface mount and the desktop mount. I quite like the idea of making one out of wood, a nice cowl. And maybe you can have a pen holder down the side or something, or a business card holder at the back. Something you can make the cowl do other than just intercom. Right, okay, that'll do me for now. Thanks for watching. Talk to you again soon. Bye bye.